In this video tutorial, I will teach you how to make a butterfly like this one here, with flapping wings, moving antennas, and you can choose to make your own designs on the wings later. This is some design I created here, so let's get started. So to make this butterfly here, let's get first we will go to desmos.com. We will click on this 3D option. After clicking on this 3D option, we will click on the XY orientation button here so we can see it in the XY plane for now, and start creating the constraints for the wings. So you can imagine the wings will look something like two parabolas or going sideways along the x-axis here. We can also do this using the log function. So let's go ahead and graph a log function so you can see what the log function looks like real quick. So this is how y equals log of x looks like, and then if you start shifting it it starts to look like this. So this can help us create a nice wing shape. We just need to reflect it along both the x-axis and the y-axis. The way we do that is take absolute values of both x to reflect along the vertically, and then take the absolute value of y to reflect horizontally. So now you can see we get a graph like this. Let's parameterize this with an a and a b here, so that way we can control the wing shape later if we want to. And then let's write our next equation. So normally a sine function would go horizontally, but let's make it vertical by switching the x and y. So we can do absolute value of x is equal to sine of absolute value of y. It'll look like this. And then let's shift it also so it look like this. And once again, let's maybe parameterize the shift as well as the scaling here inside the sine function, so we can easily control how we want to make the shift. So something like this looks great for our wing shape. Okay, next we want to add a so these, if we switch back to our 3D view, this is kind of the constraints we want to define. But now we want to define a parabolic sheet along the z-axis here. So let's say z is equal to x squared. So you can see this is kind of our sheet. And this sheet, we want to actually bound it by the functions we came up with earlier. So the way you create bounds is you add braces, and then within the braces you paste the equation you wrote earlier. So you copy this equation and paste it in here. And then you also want the other bound. So you copy this equation and paste it in here. Now, we don't want equal signs. We want everything in the sheet that is between 0 and the bound. So instead of equal sign, we're going to change this to less than. So you can see the sheet now got cut. right, so so the reason we're seeing the cut from the red line is, but not the purple, is the parabola is not wide enough to reach all the way out to the purple. So we can fix that by trying to multiply this x squared to make it a little bit wider with some other constant. Let's say we'll just call it constant e, and then maybe it doesn't like e, so let's do g. And then add a slider for g. And here we made it, let's say, a little bit wider like this, so we can see some butterfly wings now. All right, and then we have already applied the constraints, so we can hide the constraints. We no longer need to show these two equations here. So now we have this here. Now let's make the body, which is going to basically be a cylinder in the middle. So the equation of a circle with a fixed y radius, which is basically going to be x squared plus z squared is some constant k. And then we're going to multiply it by cosine of y so that we can taper the ends. So let's go ahead and take this equation here, so I don't have to type it again. Or okay, I'll just type it. X squared plus z squared is equal to some constant k. Let's add a slider for that constant so you can see there's a cylinder now. And then if I multiply by cosine of y, you can see it's starting to get tapered. But you can see the cosine of y is creating artifacts, so that's why we'll add some constraint to it and make sure it stays, let's say, within where y is less than 2.5, right? The absolute value of it, so that we cut both sides out. So now you have the cylinder in the middle and two wings. Of course, the cylinder is super thick right now, so we can thin it out by finding a better value for k like this. All right. Now to create a little head, we need the equation of a sphere. So a sphere is basically adding all three coordinates, x squared plus y squared plus z squared, and then equals to some radius. So x squared plus y squared plus z squared is equal to, let's say, a radius of 2. That's too big. 1, still too big. 0.1, okay, can work, right? And then we need to shift this along the y-axis. We need to shift it up. So basically that means we need to subtract from y. So let's say y minus 2. So it's too far out, maybe y minus 1.8. So there we go. Now we have a little head, but the head is looking a little bit too big, so let's make it 0.05. Maybe move it down even a little bit more. Okay, perfect. So now we have the head of the butterfly. Next, let's add some antennas for the butterfly. So we can basically do another log function reflected along the y-axis here. So to reflect along the y-axis, we take absolute value of x, and then we need to shift it to around there to get it to show up as the antennas coming out of the head. And we need to constrain it so the antennas don't just run off forever, but maybe up to absolute value of x equals 2 or so. So let's add a constraint that x is less than the absolute value of x, sorry, is less than 2. So there you go. So now we have some antennas. And if you hold on down on this for a little while, you'll see we can change its color. So let's make this one orange. You can see the antennas are running too far down in the back, so we also need to constrain it. So y is not so far down. Let's constrain it to say y must be greater than 0. So the rest of it's hiding inside the body here, so that doesn't matter. So now we have some antennas. Okay, so now we have a basic butterfly. Let's go ahead and add a little bit of movement to the wings and the antennas. And the way we do that is we add some timing. So let's add a variable t. Before adding a variable t, let's just say, so here it took me a little bit of time to figure out how to get the antennas to move in a good way, but it turns out I can do x divided by t. And we'll add the little slider for t. And then to move the wings up and down, we can do like a sine function on this equation of the x squared. So we can multiply this by, let me just scroll this back here. So a sine motion is like a for amplitude, sine of f for frequency of x. And then we add a variable for f. So we'll set f to sorry, not x here, t here, right? Correct. So as time moves, we multiply by an amplitude and frequency. I think I'm already using a for something else, so let's do, I'll do like, I'll do a1. You can use any other variable you want. All right, so now antennas moving around. We don't want too much motion, of course. So we're going to restrict the t here. To, I don't know yet, let's say from 5 to 9 with a step size of 0.1. So I just use these values because I figured in the last one they worked pretty well for how much antenna motion I want. So if you look at the slider here, this looks pretty okay. But you can play with the numbers to try and get your antennas to move the way you want. And then change the F a little bit here. Try and see what the timing does now. So you can see the butterfly's wings are now moving and the antennas are moving. You can play with the F a little bit more. So there you have it. Some butterfly wings are moving and the antennas are moving and there's a head to it. Finally, let's add some patterns to the wings. So you already know that the equation of the wing is this z function here with the constraint. So we just copy this equation here. So if you copy this equation here, and then add some more constraint to it for the design. So let's say within this, I want to make a circle, which would be x squared plus y squared is less than 1. So now you can see there's a green circular design that's sitting on the wing as I constrained it to being a circle here. I could shift the circle, let's say along the x-axis by subtracting from x some amount. So let's say 0.2 or -2. So you can see now there's a circle that's sitting here. If I want to reflect the circle, I can take the absolute value of x. So you can see now the circle is being reflected on the two wings. I can also do something interesting like take the sine of this x. So that seems to have gone away. What about cosine is going away? Let's try without the... There you go. So let's say if we do sine of x minus 2, you're going to get something like this. Let's add the absolute value back in for symmetry. So here you have some design on the butterfly wing. And you can see that design moves perfectly with the butterfly. Now if I hide the grid here, you can see we've created another butterfly. You can create basically whatever patterns you like on the wing by just using the equation of the wing and adding more constrained functions to it. And you can change the color from, let's say, green here to purple if you like this. If you want, you can, let's say I created one equation here for these red circles, so let me copy this one. And maybe add it onto my butterfly here as well. Did not copy. Anyhow, I don't want to make the video too long, so you get the idea, and we've made a butterfly.